reference. Look at this question. In the figure, D1 is a real silicon junction diode with a drop of 0.7 volts under forward biased condition, and D2 is a GNR diode with breakdown voltage of minus 6.8 volts. The input V input of T is a periodic square wave of period capital T, whose one period is shown in the figure. Assuming 10 RC is far greater than capital T, where RC is the time constant of the circuit, the maximum and minimum values of the output waveform respectively are. Yes, see this. If you observe this particular circuit, it is a negative clamper with V reference. See, diode is directed downwards, so it is a negative clamper. And GNR diode is also given, which acts like a reference voltage. So plus minus V reference, Vz is of course equal to V reference, that is 6.8 volt. So a negative clamper with reference voltage, in which diode is not ideal, it has a forward voltage drop of 0.7 volts. So how do we get the response then? If it is an ideal case, then without any reference voltage, we can see the output to be something like this. Okay. But it is not ideal, right? It has forward voltage drop of, diode has forward voltage 0.7 and V reference. So it goes up by an amount of, ideally it should appear from 0, and peak to a peak amplitude means minus 28. Okay. So this is the case, but 0.7 and 6.8 both have to be added. So it will go up. Something like this. It is no more 28 minus 28. What is its value? Here it is, instead of 0, it is 0.7 plus 6.8 volt. And here it is, what you expect is minus 28, but for which we need to add 0.7 plus 6.8 volts. Anyway, this peak to peak amplitude is 28. That's what I mean. So how much is the value we are getting here? It is 7.5 volt, and here it is minus 20.5 volt. So option A is correct. That's it. A very simple thing. I am directly writing the answer without much explanation. See this question. The circuit shown in figure is best described as positive clamper, negative clamper, differentiator, positive peak, clipper. Actually positive peak clamper they should write. Okay, doesn't matter. So it is a diode is direct upwards, it is a positive clamper. It's a simple one. Next topic, voltage doubler. So what is a voltage doubler? Okay, it is a circuit, electronic circuit, which produces an output voltage of DC. Right? Whose output is a DC voltage, and whose amplitude is equal to twice that of the peak amplitude of the input sine wave given. If you apply some Vm sin omega t, then output is a DC signal of amplitude is equal to 2 Vm. That's the meaning of it. That's what a circuit which performs this kind of operation is a voltage doubler. See, a voltage doubler is a device which delivers double the peak or maximum of input sine wave amplitude. If the input peak amplitude is right Vm, then its output is 2 Vm. That's the meaning of it. It's a DC signal, right? 2 Vm. It is a DC signal. It comprises, what does it contain? It comprises of a capacitor filter circuit which delivers double the DC voltage of peak input AC voltage. So we'll see, right? What it contains means capacitors and diodes, nothing else. And voltage doublers are of significant importance in devices which need high voltage and current, low currents. right? Right. What are those devices? So some devices which fall in this category are CRO, cathode ray oscilloscopes, picture tubes in TVs. Olden days, if you see in the television, we used to have the picture tube backside, big CRT, cathode ray oscilloscope, and all those things. Olden days, PCs also, if you see the desktops, personal computers and all, backside we have this CRO, right? CRT, cathode ray oscilloscope. Right, they basically make use of this voltage doublers, voltage triplers, voltage quadruplers, right, voltage multiplier kind of circuits. Okay, I draw here one simple circuit, what is its working and how these things are coming. I will come back. Let us start with its analysis, and after the analysis you will understand how these voltages VM2, VM and polarities of the output, etc. Okay, see here what I am doing is just I'm starting with a simple negative clamper. We know it's working. Right, here V input is equal to V capacitor plus VD I am taking. If I take the loop equation, now in the same circuit I am interchanging the positions of diode and resistor without changing the direction of the diode. Here if I take it, V input is equal to VD plus V capacitor. Okay, if the diode is on, how the current will flow? Here it is clockwise. And here if the diode is on, how the current flows? Clockwise only. So how will the capacitor charge? If you look here, the capacitor will charge with polarities plus minus. Here also the capacitor will charge with polarities plus minus. No issues. And what about the working of these circuits? We have already gone through the working of this circuit. The same working you can see here also. There is no difference in the working of the circuits. Both have the same working. Right? Why I changed the position of the capacitor from here to here means I want a DC output. That's why. So generally we have a practice of taking output here. Some circuit I have like this, and we write input and output. Right? It's a not a good practice to write input and output here. Just I want a DC output, so I changed the position of the capacitor. We are well aware that both have the same working. Okay, so just I am recollecting the things, taking both the circuits together, and over the interval 0 to t by 4, during the first quarter cycle only the diode is on. You take any one of these circuits, that's what is true. Input is positive. Then once the diode is on, what is the circuit here? It's almost acting like short circuit, and V input here, and the current flows like this. Capacitor will charge with polarities this way. So V input is equal to V capacitor plus VD. The diode voltage is almost negligible. So V capacitor is approximately equal to V input. Practically speaking, slightly less than V input, because first the input has to rise, next the capacitor charges. Let us take this circuit. The same thing, like once the diode is on, it acts as short circuit. Input and the current is flowing in this direction, the capacitor will charge like this. Okay, so here V input is equal to VD plus V capacitor. VD is almost negligible and V capacitor is approximately equal to V input. Fine. And at t is equal to t by 4, I am now writing the common statements. Right? At t is equal to t by 4, V input is reaching its peak amplitude. Let me take the same example like 5 sin omega t. V input is 5 volts, and due to small delay, V capacitor is equal to 4.9 volt. Both the circuits, common statement. It is a common statement. This is also common statement. Now at for t greater than or at t is equal to t by 4 minus, at t is equal to t by 4 plus, input falls below its peak amplitude, maybe 4.9 volt, and V capacitor by that time reaches 5 volt. Okay. If so, what about Vd? Both the cases only I am speaking. V input minus V capacitor, 4.9 minus 5 is equal to minus 0.1 volt. Anode to cathode voltage of the diode is negative. Immediately diode becomes off. Once the diode is off, circuit 1, how it appears? This way. And circuit 2, how it appears? That's it. In both the cases, what you can see, capacitor will charge up to 5 volt with polarities like this. Here also the capacitor will charge up to 5 volts with polarities. Here input and Vd, I am writing input Vd. Okay, is there any path for the capacitor to charge or discharge further? No, the capacitor can neither charge nor discharge. Simply acts like DC source or battery. Both the cases I am speaking. Okay. So Vd is equal to V input minus V capacitor. Here also Vd is equal to V input minus V capacitor. It is true, right? So that implies V capacitor is equal to 5 volts, which is a DC signal in both the cases. Okay, and what about Vd? It is V input minus V capacitor. So many times I explained this. 5 sin omega t minus 5. That's it. You see, whether you take this circuit or this circuit, working is same. Vd does not change, Vd equation doesn't change, and V capacitor equation also doesn't change. Okay, that's it. So this is the point I am using, nothing else. Okay, so here you may give 5 sin omega t or 5 plus 5 sin omega t or 10 plus 5 sin omega t. The capacitor voltage will change, Vd equation does not change. We are well aware of it. Okay, so here what I am doing further is whether you take this circuit or this circuit, if I give something like 5 plus 5 sin omega t, okay, here 5 plus as usual V in is equal to V capacitor plus Vd. We know that. Or directly I am writing it, we know. Why, how many times do I write this? Both the cases, V capacitor will charge up to the peak amplitude, V input peak or V input maximum. What is that value? 5 plus 5, 10 volts. In both the cases, Vd is equal to V input minus V capacitor. it is equal to 5 sin omega t minus 1. Is it not so? Okay, why I took 5 plus 5 sin, it need not be 5 plus 5 sin omega t, 2 plus 5 sin omega t also, or 7 plus 5 7 omega t. In all the cases, what is V capacitor? V input maximum, and VD equation doesn't change. Okay, right, we call diode, if you take voltage across the diode, it is a combination of DC and AC, its equation is standard. Capacitor voltage only changes. Now voltage doubler I mentioned. Voltage doubler means output is a DC signal whose amplitude is twice that of the input. Peak amplitude. Okay, that's the statement I said. Okay, suppose, right, what I want is, I want 10 volts from 5 sin omega t. That's what my actual target is. But this is what we have seen. Now what I am doing is, how to achieve this 5 plus 5 sin omega t? It is the output of a positive clamper. So let us take a positive clamper. Let me take C1 and D1. Input is 5 sin omega t. Then what do we get here? Let me take, it is VO1. It is equal to 5 plus 5 sin omega t. This is what you are getting here. Now give that 5 plus 5 sin omega t as input to our negative clamper. Okay. Then 5 plus 5 sin omega t is given as input to this negative clamper. Then what happens? Here actually, if you observe this, this will charge up to 5 volts. Because, right, if the diode is on, current will flow like this. Here, what about the capacitor voltage? Here we have seen V capacitor is equal to 10 volts. Is it not so? And VD is 5 sin omega t minus 5. So let me take, it is VO2. VO2 is equal to 5 sin omega t minus 5. And what about VD2? It is plus minus 10 volts. Its maximum value of input. It is equal to 10 volts. It is like 2 Vm. It is Vm sin omega t plus Vm. It is Vm sin omega t minus Vm. Okay, it looks like VO2 here, but what I am expecting only DC. So better what we can do, let us take this circuit, positive clamper, and interchange the positions of diode and capacitor, D2, C2. C1, D1, D2, C2. Okay, it's not VD2, VC2. Now what is voltage across C2? If I take this, voltage across C1 is, right, if I give here, okay, five sin omega t, if I give here, then it is plus minus 5 volt, and here it is, oh, I should change the direction of the diode, no? Yes. So then this capacitor will charge up to 10 volts. Both circuits are same, right? If I give here 5 sin omega t, right, 5 sin omega t to this circuit or this circuit, the operation remains the same. Instead of 5 sin omega t, I am giving 5 plus 5 sin omega t. So what about V capacitor and Vd? Right. Now I can just change its name like C2 D2 D2 C2, doesn't matter. Now how to get 5 plus 5 sin omega t? It is output of a positive clamper for an input of 5 sin omega t. That's it. This is the simple circuit we can take, and input is a sine wave of peak amplitude 5 volts, and output is, this is my overall output, final output. It is 2 Vm. If I give Vm sin omega t as input, its output, its overall output is a DC signal of amplitude is equal to 2 Vm. It's a very, very simple thing. Okay. So let me take that final circuit with statement. So this is one possible circuit. Now I am generalizing it. Vm sin omega t is my input, and this capacitor will charge up to Vm, and this capacitor will charge up to 2 Vm. Diode D1 acts like positive clamper, D2 acts like negative clamper. Okay. So here C1, I can write V capacitor 1, it is equal to minus Vm. I can write, because we have a practice of taking the capacitor voltage from top left to right, but it is appearing from right to left. Okay, and V capacitor 2, it is equal to 2 Vm, which is our overall output, and D1 acts like positive clamper, and D2 behaves like negative clamper. These are the observations. Very, very simple thing. Okay. And vice versa is also possible. What I mean to say is, here first I used positive clamper, next negative clamper. Vice versa. Means first we can use negative clamper, next positive clamper. See that example also. I am taking a positive clamper, input, capacitor, and Vd. Okay. We know here V input is equal to V capacitor plus Vd. Of course, I took Vd from cathode to anode, right? And the same thing I can even write this way. Let us change the positions of diode and capacitor. It is input and Vd, V capacitor. Okay. Like this. Here V input is equal to Vd plus V capacitor. We know during the first half cycle, whether you take this circuit or this circuit, as long as input is positive, diode does not conduct. Okay. Here, if the diode is on, the current will flow in anti-clockwise direction. We know. Okay. So, anyway, over the interval 0 to t by 2, diode is off. Right. And over the first negative quarter cycle, that is from t by 2 less than t less than 3 t by 2, diode is on. Both the circuits I am speaking. So that the diode starts conducting, it almost acts like short circuit, and the current will flow this way. So capacitor will charge with polarities like this. The same story here also. Almost the diode acts as short circuit. This is how the current will flow. The capacitor will charge with polarities like this. Okay. Now at t is equal to 3t by 4 minus V input is reaching its negative peak, but due to small delay V capacitor is slightly greater than minus 5, and at t is equal to 3t by 4 plus V input is just going above its peak amplitude, and V capacitor falls completely up to the negative peak of input. You take either this or this, operation remains the same. Both the circuits I am speaking. If that is the case, what about Vd? Vd is equal to, in both the cases, okay, input minus V capacitor, it is equal to minus 4.9 minus of minus 5, it is plus 0.1 volt. Means the anode to cathode voltage of the diode is equal to minus Vd. Cathode to anode is plus 0.7, which means anode to cathode it is minus 0.1 volt. Implies diode is off. I am again recollecting the operation of first two clamper. So whatever may be the position of diode, its direction, if diode is on, current will flow in anti-clockwise. That's it. So the equivalent circuits are like this. Here it is open and the capacitor input. Okay, so here once the diode is off, there is no path for the capacitor to charge or discharge. That's it. So the capacitor has voltage with polarities like this. Let me take it is C1 and it is C1 or C1 or C2, anything you can write. C. Okay, later I will write. Is it not so? So here it is Vd and here it is Vc, V capacitor. What are the polarities of capacitor voltage? Plus, minus. So here if V input is equal to Vm sin omega t, then what is V capacitor here? Minus Vm. Instead of 5 I am directly writing. And Vd is equal to Vm sin omega t plus Vm. We know. In the same circuit, if V input is equal to, so here what happens? The capacitor will charge up to the negative peak of the input. That's what we should observe. Right? It is nothing but the negative peak of the input, V input minimum. Okay. Now instead of Vm sin omega t, that's what I can write. I am not extending it like 5 sin omega t etc. Right, minus 5, generalizing it. We know the operation. My concern is to tell you that this circuit and this circuit have the same operation. Circuits are not same. It all depends upon where you are taking the output. Okay. Here we are taking the output across the diode. Here we are taking the output across the capacitor. Across the diode it is a combination of AC and DC, and across the capacitor it is pure DC. Okay, but working is same. Now the same circuit I am taking either this one or this one. If my input is like Vm sin omega t plus Vm, What about the response? The capacitor will charge up to 2 Vm. Right here the polarities are like this, 2 Vm. And diode voltage we know. Okay, diode voltage is equal to, diode is upwards. Oh, sorry. Here it should be minus. Very sorry. Negative clamper, no. So V capacitor, it is equal to V input minimum. What is input minimum? Minus 2 Vm. That's true for both the cases. And what about Vd? Vd from cathode to anode, it is Vm sin omega t plus Vm. That's it. That is true. Whatever may be the position of diode and capacitor, as far as these circuits are concerned. Now, how to achieve Vm sin omega t minus Vm? It is nothing but output of a negative clamper. So, let us take a negative clamper. After negative clamper, what we can write here, this is what. So, here it is Vm sin omega t only. Okay. Then this capacitor will charge up to Vm and this will charge up to 2 Vm. It is D1, D2, C2. Is it not so? Now the same thing, negative clamper. Change the direction, sorry, positions of diode and capacitor. Here now it is D2, C2. C1 it will charge up to Vm. Input is Vm sin omega t. D1. C2 will charge to 2 Vm, but polarities from bottom to top. Bottom to top. Then how can I take my final output? I should also take the final output from bottom to top. If I take from top to bottom, it is minus 2 Vm. If I take from bottom to top, it is plus 2 Vm. In both the cases, right, if I take Vc1, V capacitor 1 is equal to Vm, I am speaking about both the circuits, and V capacitor 2 from bottom to top, it is 2 Vm, and Vd1, D1 behaves like negative clamper. And D2 behaves like positive clamper. That's it. Okay. This circuit is only, this is a voltage doubler circuit. This is what is shown at the very beginning. This is like a negative clamper. Okay. C1 will charge to Vm with polarities and D1 behaves like negative clamper. And D2 behaves like positive clamper. And here C2 will charge to 2 Vm with polarities from bottom to top, and output is also having polarities from bottom to top. So input is a pure sine wave of peak amplitude Vm. Output is a DC signal whose amplitude is equal to twice the peak amplitude of the input. That's it. Okay. This is the idea behind the basic voltage doubler circuit. Okay. Next, there is one more voltage doubler circuit. We can see this one. This circuit and this circuit both are one and the same. I will show you how it is. Let me take D1, right? Anyway, supply polarity is just for our understanding purpose. I am writing it so, and it is like D1 and it is C1. It is D2 and it is C2. Now look at the circuits, how the circuits are same. From the positive terminal of the supply, right, it is going to the positive, anode of D1. From the positive terminal of the supply, right, it is going to anode of D1. Similarly, the same point is going to the cathode of D2. From anode of D1, cathode of D1, capacitor C1, one end of C1, one end of the capacitor C1, and other end of C1 is going to the negative terminal of the supply. Other end of C1 is going to negative terminal of the supply. Okay. Next, from the anode of D2, one end, anode of D2 is connected to one end of the capacitor C2. Anode of D2 is connected to one end of the capacitor C2. Other end of the capacitor is going to the negative terminal of the supply. It's going to negative terminal of the supply. That's it. Circuit wise, both are looking similar. Next, here it is mentioned from cathode of right, okay, in the direction of C1 is charging in the direction of D1. So it should charge with polarities plus minus Vm. C2 also should charge in the direction of D2. If D2 is on, the current will go upwards, so plus minus. Is it not so? Next, output is taken from anode of cathode of D1 to anode of D2. Cathode of D1 to anode of D2. Okay. So if you see this voltage is Vm and this voltage is Vm. Vm plus Vm, total output is 2 Vm. The voltage between these two is Vm, and if I take this loop also, right, it is just the voltage between these two terminals, it is 2 Vm. So both the circuits are one and the same. Any one we can take for our understanding purpose. See, in the exam to confuse us, they may give the circuit this way or anything is possible. Okay, let us have a look at its working. Okay, here during the positive quarter cycle I am taking, it's not half cycles, it is quarter cycles. First quarter cycle means 0 to t by 4. Then if you look at it, it's positive means D node, anode of D1 is connected to positive terminal of the supply, D1 is on, and cathode of D2 is connected to positive terminal of the supply, D2 is off. 0 less than t by 4. Okay, oh, the small correction, t by 4, somewhere I wrote t by 2. 3t by 4, sorry friends. Here I wrote properly. Let me take over the first quarter cycle, t by 4. D1 is on and D2 is off. So what is our equivalent circuit? D1 is almost acting like short circuit. D2 is open circuit. We have one capacitor here and one more capacitor here. So how the current will flow? It is like positive cycle, D1 and D2. Current can flow only in this direction. Capacitor will charge with polarities plus minus. It is not looking. Is it not looking like our regular negative clamper? Of course, D1 acts like a clamper. C1 will be charging up to the peak amplitude of the input, positive peak of the input amplitude. Okay, so if I take the waveforms, VC1 I am writing, it will charge up to the peak amplitude of the input. And we know it is 0 to T by 4. For T greater than T by 4, diode will be off and the capacitor holds that voltage. And is there any possibility for current to flow through C2? No. Because one end of C2 is coming to negative terminal and other end is not connected. Path is not completed here. So there is C2 acts as short circuit. So what I can write is D1 and we can write Vs is equal to Vd1 plus V capacitor 1. Okay. Vd1 is almost negligible, implies V capacitor 1 is approximately equal to Vs or V. Okay, and C2 acts as short circuit. For T greater than T by 4, D1 is off and V capacitor 1, it is charging up to Vm, not to Vm, sorry. Vm, we can take so. Okay, like this. Then what about Vc2? Here it is simply 0. Right. Next, T by 4 to T by 2, no diode conducts. T by 4 less than T by 2, no diode conducts. Means both the diodes are off. Okay, fine. Capacitor voltages are this way. Next, from T by 2 to 3T by 4. Here what happens? Negative cycle. Then D2 is on and anyway D1 is already off. So T by 2 less than T less than 3T by 4. D1 is anyway off and D2 is on. Once D2 is on, anyway it is off. Voltage across C1 is Vm with polarities top to bottom. And D2, let me change the color here. Okay, let me take V capacitor 2 from top to bottom. and V input is a negative cycle. No, negative cycle, for our understanding purpose I am changing the polarities, minus plus. Okay, it is like connecting a negative source. And D2 C2, how the current will flow? Okay, current flows from positive to negative terminal of the supply. So here the current starts positive terminal, it comes down and it flows through the diode D2, and finally it will go to the negative terminal. So current is flowing in this direction. See this, downward. Even though Vs is negative, the current direction and right, so that the capacitor C2 will charge with polarities plus minus. Is it not so? And what about V capacitor 2 then? It is equal to, right, the capacitor voltage will be positive only, because look at the polarities top to bottom. The convention I followed is from top to bottom, and the current is flowing from top to bottom. The polarities remain the same. Okay. And here also, if you take this loop equation, if you want, we can further write it this way. The same circuit can be even redrawn D2 and C2. Even we can write like this. Okay, diode is taken up, removing C1, D2, C2. Okay, so anode to the negative terminal and cathode, right, and other end is coming to plus sign, is coming towards Vs with polarities this way. So obviously the current is flowing in this direction and it is plus. If you rotate the diode, right, rotate the circuit upwards, this is what we can see. Okay, here also neglecting the voltage drop across diode, entire input can be seen across the capacitor. But V capacitor we are taking from positive to negative terminal only. Okay, it is V capacitor 2 is like this. So to what level it will charge? Once the diode is on, the capacitor will rapidly charge towards the peak amplitude of the input. So V capacitor 2 at T is equal to okay. So once the diode is on, C2 will charge towards the peak amplitude of the input, negative peak only. Okay. So at T is equal to 3T by 4, V capacitor 2 is equal to Vm, and D2 becomes off. That's it. Okay. So finally, what about the overall output then? It is overall output is equal to, so in steady state, what we can write is, anyway, if you want, you can take this one. This is negative, but our V capacitor 2 is positive. What about overall output? It is V capacitor 1 plus V capacitor 2. You see the polarities, how the capacitors are charging. overall output is equal to V capacitor 1 plus V capacitor 2, it is 2 Vm. Of course, in steady state I can say, in steady state, this diode is open circuit and other diode is also open circuit. Overall output C1, C2, it has charged up to Vm, it also has charged up to Vm. That's it. Okay. This is the idea here. This is how it looks like a bridge type rectifier or center tapped rectifier circuit also looks something different, not something similar, not exactly. It also looks like some bridge kind of a full wave rectifier. That's why it is known as full wave voltage doubler. Okay. So first one is half wave voltage doubler, second one is full wave voltage doublers, like this. Now let us have a look at some problems on these voltage doubler circuits. It was a question asked in electronics paper GATE 2015 set 3. In the circuit shown in figure, assume that the diodes D1 and D2 are ideal. In the steady state condition, the average voltage VAB of the voltage across the 0.5 microfarad capacitor is. See, they have given the circuit like this. To be frank, there is nothing in this. You see, this is our input. Now, take this diode upwards. Next, from this point, we have one diode D2. From D2 to capacitor C2. That's it. See, this is how this circuit and this circuit are one and the same. What is it not a voltage doubler? Input is 50 sin omega t. So it will charge up to 2 Vm, that is 2 into 50, 100 volts. This will charge up to 50 volts with polarities from right to left. That's it. So across 0.5 microfarad, it is 100 volts. A very, very simple question. The students will be simply scared by looking at the circuit, but nothing is there. It is our regular voltage doubler circuit. Next, the diodes and capacitors in the circuit shown are ideal. The voltage V of t across the diode D1 is. Again, you see, it is a voltage doubler circuit. Instead of sine wave, they mentioned cos. Cos or sine, the operation remains the same. Just to confuse us, they give so. Okay. So here this will charge up to 1 volt because the peak amplitude with polarities like this, and this will charge up to 2 volts with polarities bottom to top. And D1 behaves like negative clamper. D2 behaves like positive clamper. Output of negative clamper, Vm sin omega t minus Vm. It's a sine or cos, right? V of t, it is like cos omega t minus 1. 1 sin 1 cos omega t minus 1. Option A is correct. It's a very, very simple question actually. Look at this. In the voltage doubler circuit shown in figure, the switch S is closed at t is equal to 0, assuming D1, D2 to be ideal, the load resistor to be infinite, and initial capacitor voltages to be 0. 0 initial conditions, RL is very large. the steady state voltage across the capacitor C1 and C2 will be. Yes, we are well aware. See, it will charge up to 5 volt with polarities plus minus, and here this diode is on, means right, this C2 will charge with polarities plus minus to 10 volt. So what I can write, Vc1 and charging polarities are same. Vc1 is equal to 5 volt, and Vc2 capacitor polarities they gave like this, and what we get, the current voltage polarities bottom to top. So Vc2 is equal to minus 10 volts. Okay, option D is correct, 5 and minus 10. The circuit shown in figure is best described as, it's not bridge rectifier, frequency discriminator, ring modulator, voltage doubler. Option D is correct. Look at this question. In the following circuit, the input voltage Vi is 100 sin 100 pi t. Okay. For large R, the average voltage R across R in volts under steady state is nearest to 2. Okay, right. Without this we have seen. And what about this circuit? It is a voltage doubler only. See, first positive quarter cycle, the current will flow like this. It will charge up to Vm. What is that Vm? 100 volts. And negative quarter cycle, first negative quarter cycle, it is first positive quarter cycle. Right, and during the first negative quarter cycle, D2 will be on, capacitor C2 will charge up to Vm, that is 100 volts. Overall output, it is a voltage doubler, no, 200 volts to Vm. Okay. Next, see this question. It is again looking like voltage doubler. The thing is, they changed the direction of diode D2. Both are not in the both should not be in the same direction, right? If the diode D2 is taken this way, then it is voltage doubler. Now what they did, they changed the direction of D2. Okay. See this. During the first positive quarter cycle, means it is like this, D1 as well as D2 both are on. So it will charge up to 10 volts, and see the direction of the current here. This will also charge up to 10 volts. During the first positive quarter cycle, both D1 and D2 are on. So that the capacitors will charge like this. For t greater than t by 4, both D1 and D2 will be off. Then what about overall output voltage? Simply it is 0. Okay, 10 minus 10. Overall output is 0. See this question. The diodes given in the circuit are ideal. At t is equal to 60 milliseconds, Vpq in volts is. Okay. Let us have a look at its working first. During the first positive quarter cycle, positive cycle, right, half cycle, anything. Okay, quarter cycle I am taking. If input is positive, let me give some names, D1, D2, D3 and D4. C1, C2. Okay. Now, what happens if it is a positive cycle? Then it looks like D1 is ready to conduct, its anode is connected to positive terminal. Okay, but what about D3? Its anode is connected to negative terminal. So even though D1 is ready to conduct, D3 doesn't conduct. Then how the current can flow from positive to negative terminal of the supply? It is not possible. Only D1 is on, D1 is ready to conduct, but as D3 is not conducting, the path is not complete, and hence D1 also does not conduct, I can say. Similarly, take D3, D2 and D4. D2, if you see, its cathode is connected to the positive terminal of the supply, so D2 cannot conduct. And D4, its cathode is connected to negative terminal of the supply, it is ready to conduct, but which is which doesn't D2 doesn't allow D4 to conduct, because once it is open circuit, it is open, where is the path for D4 to conduct? Okay, its anode is looking like going towards positive and its cathode is going towards negative, but in between we have D2 which is not conducting. Means no diode conducts during the first half cycle, I can say positive. During the first half cycle, 0 less than t less than t by 2, no diode conducts. So that what is the equivalent circuit we can take? See, this is what we can see. Actually, it is ready to conduct, but as it is not conducting, there is no path completion. How the current can flow? Positive to negative terminal, the current has to flow. No? Is it possible? No. Similarly, here, even though D4 is ready to conduct, D2 is not conducting. So, positive to negative terminal, how the current can flow? Not possible. No diode conducts. And both the capacitors act as short circuit. This is short circuit and this is also short circuit. It is the point P and it is point Q. Okay. During negative half cycle, negative quarter cycle, I can say, means it is minus and it is plus. Just for our understanding purpose, I am changing the polarities. Here, D1 cannot conduct because its anode is connected to negative terminal, D1 is off. Okay, what about D3? Its anode is connected to positive terminal and its cathode is connected to negative terminal through C1. Now there is a scope for current to flow in this way. Even though D1 is off, through D3 and C1 current can flow. Done. Good. Next case. Cathode of D4 is connected to positive terminal. D4 doesn't conduct. And what about D2? Its cathode is connected to negative terminal of the supply. Good, it is ready to conduct. Then what about the path? Now there is a possibility for current to flow through C to D2. Means this is how the current can flow from positive to negative terminal of the supply. So D1 and D4 are off, D2, D3 are on. Okay. So let us take the redraw the circuit. I'm just changing the polarities for better understanding, nothing else. So in one case the current is flowing like this. So the capacitor will charge to Vm, the peak amplitude here, right? And second case, the current is flowing like this. This will also charge up to the peak amplitude. Vm. It is the point P and it is the point Q. VPQ is our output. Diode is directed upward. It behaves like positive clamper, no? Negative, during negative quarter cycle only we took the analysis. Okay. So what about VP? VP or D3 and D2 both behave like positive clampers only. Okay. VP is equal to Vm sin omega t plus Vm. And VQ is equal to minus V, and VQ is equal to minus Vm. So what about VPQ? It is equal to Vp minus VQ. It is Vm sin omega t plus 2Vm. This is our output equation. Okay. And okay, this is fine. What they are asking, find the output at t is equal to 260 milliseconds. What about its time period, friends? T is equal to, right, it is like 2 pi f into t. F is equal to 50. So t is equal to 1 by f, 1 by 50. It is equal to 20 millisecond time period. Okay. So at t is equal to 60 millisecond, which means 3 times the time period. At t is equal to 3, at the end of every cycle, Vm sin omega t value becomes 0. Is it not so? So V input or Vs is equal to 0. So Vpq is equal to, it is like Vm sin omega t plus 2Vm. It is 0 plus 2Vm. It is 2 into, input has the peak amplitude. What is the peak amplitude here? 100. 200 volts. That's it. Okay. This is how we can take the equations. See, I changed the polarities of Vs here to show you the direction of the current flow. But always the polarities of Vs are from top to bottom only. Please do observe that point. Okay, that's it. This is how we can solve this problem.